Now, what I really like that phosphate does, if you put it in a marinade and you vacuum tumble or inject it, now you're gonna get that negative charge in there. That's gonna make the proteins in the sarcomere, it's gonna make them repel from each other because you have that increased negative charge from the phosphate ion. But phosphate's also alkaline, so it's
Mm.
increasing the pH. So
Hmm.
it's giving it even more of a negative charge. So that's really cool.
Hello, meat folks. Welcome back to the Meatspad Podcast. It's your happy, hungry host, Phil. We're reaching way down into the South today with Dr. Wes Schilling at Mississippi State University. And first off, Dr. Wes, thanks for joining us.
Oh yeah, my pleasure,
Yeah,
Phil.
yeah.
Thanks for having me on here. I'm excited.
Yeah. Well, so recently I had been perusing through some of the newer websites that are on the American Meat Science Association main page and everything. And a topic that came up that I think is interesting and we need to talk about that you wrote a little bit of a fact sheet on, well, it was phosphates. And so let's go down that road because we have a lot of listeners that are medium to small size processors who are doing value added and probably are wondering, I do all of these steps, I add all of these different ingredients. Why do we do this? And phosphates is one of them. And so maybe let's just talk about what's the deal with phosphates in meat.
Okay, well, I am a big advocate of phosphates, Phil.
Okay. Yep.
I think that they get a bad rap. The, but when you use them with salt, with all kinds of processed meats, whether they're marinated meats or hot dogs, which I like to call tube steaks, or deli meats, they're going to give you added value as far as protein extraction and yields.
Hmm.
So they're the hardest thing to solubilize in a brine. So you always put them in first.
Hmm.
Common issue that we see when we go to plants is a lot of times they're not getting very good yields, and it's because they don't have the phosphate dissolved very well.
Okay.
So that's one thing that we see quite a bit. But we are, well, I say we, but it's me. I think that phosphates get a bad rap. Um, ATP is in our muscle. We need phosphorus, which is a key component of ATP.
Hmm.
Very important micronutrient for us. So I think that we should not bow down to those that say you shouldn't have phosphated meats, if that makes sense.
Right. Well, and for those who have used it, you probably realize, I mean, you could take a big old vat of water, and it's only a little bit that goes into it, but it does make a big difference as far as yields and um, and adding value to that processed meats.
Yeah, absolutely. You can use about 0.4% of a phosphate, and it will make your yields. It will make for a marinated product, it'll make something tender and juicy.
Yeah.
I was telling my food chem class yesterday about the pork industry back in the 1990s when they started marinating and adding water, salt, and phosphate um, to pork, tenderloins and chops, and it really helped because
Hmm.
when people would cook pork to 180 degrees, which is also crazy,
Yeah.
then it'd still at least be palatable.
Yeah.
So it'll make it tender and juicy and cover a lot of our cooking and sins and other things.
Yeah. Well, and I want to elaborate a little bit on the chemical aspect as you mentioned it, but first I do have to confess my sins. I remember one of the first times I was working with phosphates, and this was 100 years ago, back when I was Dr. Bob Delmore's graduate student, very first graduate student, and he had me making up a bacon brine with some phosphate, and I saw the little amount. I just kind of mixed it in with or mixed everything else, and I threw the phosphate in, and I remember it almost turned into like a rock down in the bottom
Mhm.
of the brine that I was trying to make, and so I can't emphasize enough, guys. You got to dissolve that stuff ahead of time, and oftentimes, usually with our little meat lab here on the campus of the University of Idaho, we actually take a smaller batch of water and get that dissolved in first, and then mix it into the larger amount if we're using phosphates in brines. So,
Yeah, and that's a smart thing to do. And
yeah,
then you want to go ahead and use it right after you make it because the phosphate can settle out. So
yeah,
it's very important to do that as well. You
yeah.
can also use blends of phosphate that are agglomerated, and those will be more soluble and
Okay,
more functional. They're usually a little more expensive, but if you try them out in an application you have, a lot of times they'll be worth it because of the yields and the quality they give.
right. Tell us a little bit, if you can, about the chemistry. What is happening with that phosphate when you incorporate it into meat?
Okay, so that phosphate has a phosphate and oxygens on it, and it has a negative charge.
Hmm.
So with that negative charge, if you chop that up with meat, like making a meat emulsion, it's going to help unfold the myosin and the actin, just like the salt does, so that that protein is ready to emulsify. And so it's going to give it, it's going to add to the salt's ability to do that, and it's going to give a firmer texture, and it's going to help increase its ability to bind water. Now, what I really like that phosphate does, if you put it in a marinade and you vacuum tumble or inject it, now you're gonna get that negative charge in there. That's gonna make the proteins in the sarcomere, it's going to make them repel from each other because you have that increased negative charge from the phosphate ion. But phosphate's also alkaline, so it's
Mm,
increasing the pH. So
hmm.
it's giving it even more of a negative charge. So that's really cool. And then a third thing that almost no other ingredient does, there's probably some, but that is it will actually disassociate the actin and myosin bond
Okay.
because you could think because that's what ATP is doing in muscle contraction in a live person
Oh
or
yeah.
animal, so it can do that as well, which is very important. In general, that's the diphosphate form doing all of that, which is cool. And a couple other things phosphates do. If you have a monophosphate in your blend, it'll give you buffer capacity. So if you're
Okay.
using an acid marinade, you want to have a monophosphate. If you've got hard water, you want to have something like hexametaphosphate or other polyphosphates. And that's where the blends come in and are very helpful because they have different chain lengths of phosphates.
Okay, so you just said a lot in a short period of time, and so I want to unpack a little bit more of that. But first off, would you say that most of the ingredient companies, if folks are interested in some of these different varieties of phosphates, they just need to talk to their ingredient company supplier and let them know what it is that they're working with. And especially you mentioned uh, water chemistry. And I mean, we have to
Hmm.
really be aware of this. If you're on a well, or even if you're on a municipal water source, know what your water chemistry is, because there are ions and different elements in there that are going to affect that final product. And so that was really fascinating that you mentioned that. But would you say that most ingredient companies would be able to kind of tailor a particular phosphate blend for a particular application?
Oh, absolutely.
Yeah.
There are some very intelligent people at ingredient companies, both at the phosphate companies as well as some of the brokers as well, and they understand what the different phosphate products will do.
Mhm.
Um, Unfortunately, a lot of the processors are just going to ask for sodium tripolyphosphate, but
Yeah.
it's not always going to be the best choice. It will generally be the most inexpensive,
Mm.
but not the best choice. But you're absolutely right about that. There's definitely people out there that will be happy to help them make money because it'll help them make money.
Yeah, yeah. Well,
Yeah.
build that good relationship, that client relationship. Um, so I want to back up just a little bit because you said it again a lot. You said that phosphates are going to be more alkaline, and so they're going to raise pH. And so let's remind
Hmm.
some of the folks out there. Hopefully, all of our younger listeners who've just taken their meat science classes, meat chemistry classes, are aware of how impactful pH is to meat processing. But let's just go ahead and unpack that just a little bit and talk about meat chemistry, muscle pH, meat pH, and how that's going to affect how that phosphate's going to work with it.
Awesome. That
Yeah.
that is exciting.
Okay.
The yeah, the so one of my favorite words, especially in food chem lecture, is isoelectric point.
Yes.
So the isoelectric point of approximate, if you combine myosin and actin together, will be somewhere close to 5. So you're trying to increase that pH away from that isoelectric point. And beef might be 5, 4, 5, 5-ish, somewhere in there. Pork a little higher, and then our chicken's generally about 5.8 to 6.
Mm,
So if we add phosphate to it, it's going to take that pH of chicken breast from maybe 5.8 to 6.2.
mm.
So not only is it going to add that negative charge, which increases the space in the sarcomere, it's also going to raise the pH, which also does the same thing. And it's because it's moving it away from the isoelectric point further. And so it has a greater overall negative charge. And that's what a meat science nerd likes to call awesome.
Or even groovy, maybe. I don't know.
Groovy's probably better, but I'm kind of stuck on awesome.
That is so cool. I like to talk about in my class about the isoelectric point and how water is a polarized molecule. And when you get to this point called the isoelectric point, for those who aren't meat chemists out there, that's where we have essentially no charge with that protein, with the muscle protein. And you mentioned sarcomere, actin, myosin. These are our contractile proteins. That is what makes
Hmm.
muscle contract. And so the more that we can make them kind of open up by adjusting that pH, the greater ability we're going to be able to get water and other solutions in there to help enhance the meat products.
Hmm.
Right. Yeah.
And that'll increase yields, and it'll
Yep.
also make it more tender and more juicy.
Yeah.
And
Yeah.
so consumers are happy,
Yeah.
processors are happy. We're happy because we got to talk about isoelectric point. It's all good.
That's not a common conversation, I guess you get to have every day, huh? So
Yeah, usually I'm just talking to myself in food chem class. It's like today we're going to talk about
yeah. Oh, that's
that.
pretty cool. That's really cool. Um, so maybe so let's expand a little bit more on are there limitations to using phosphates in meat products?
Yeah, the legal limit is 0.5%
Okay.
for a phosphate in most processed meat products, but in general, it's self-limiting. You
Okay.
don't want to go greater than about zero point 0.4 in most applications because you're going to start seeing a texture that's not as desirable as you want, as well as a soapy type flavor.
Oh, right.
So if you go zero point 0.4, you're generally going to do really well. I say the rule of thumb is, though, try the zero point 0.5 because if you get better yields, it's still good texture. Go
Yeah.
with it, but generally you're going to have to dial back down to about zero point 0.4.
Yeah. I've heard of some folks that yeah, go a little too heavy on that and almost kind of make a rubbery texture out of
Yeah,
that.
that that
Yeah.
that defines the texture very well.
Yeah.
Absolutely.
Yeah, yeah. We don't want to turn these into ping pong balls. We want to still maintain that nice mouthfeel with the
Yeah,
product.
no door stops.
No door stops. Exactly. Yeah, yeah. Um, all right. So that was really good to mention to our processors out there that maybe are making their own formulations. The 0.5 percentage maximum use. But then are so you've mentioned that there are folks out there that may have that may not care for the fact that we're using this external mineral. And so, are there other alternatives that might be available for use as an alternative to phosphates in processed meats?
There absolutely are. they aren't necessarily going to give you as good a function as phosphates,
Right.
but there definitely are. In general, you have to use a multi-prong effect in
Okay.
order to be able to get similar type yields. But a lot of times people will use like soy proteins, carrageenans, things such as that that'll give you texture and yields. Um, there's different antioxidants that people might put in there because phosphate's also a very good antioxidant. And if you
Mm-hmm.
have metals, you need something to chelate. So you might be putting in something like a rosemary extract or oregano extract or something like that as well. There's also a lot of natural flavors that are marketed as phosphate replacers. So I'm not 100% sure what they are.
Yeah.
But if I was gonna guess a little bit, they're probably citrus type fibers. They might actually even have some natural phosphate in them
Mm-hmm.
because generally, if you're gonna do a phosphate replacement, you're gonna have something that's natural that will be able to disassociate myosin and actin. So
Mm-hmm.
to me, if I was someone making those products, that's what I would be trying to do.
Okay. Yeah. In the end, it's a mineral. It's not something that we need to be, or it's an element anyway. But it's something. It's not something we need to be afraid of. It's in our bodies constantly. You mentioned ATP. For those who are outside of the biological community, that's your energy currency in your body. And
Mhm.
so the P on ATP, adenosine triphosphate, is phosphate. And so it's something that's already in us. It's something our body definitely already needs. So it's nothing to be afraid of. It's used in very small amounts if you're using the elemental versions of that. But let's not forget these plant alternatives probably have it in it as well. And so,
Mhm.
or it's going to act in a similar manner. And so, either way, we're trying to target a final product that's desirable to the consumer. If folks are okay with some of these plant alternatives, and let's not forget some of those, especially soy, falls under the allergen categories. So there's even more
Mhm.
labeling that has to go along with that. Then it's up to the processor to figure that out. But phosphates, I mean, it's nothing to be afraid of.
Yeah, and if I can add, Phil, there's only
Yeah.
really two issues health-wise that could come from phosphates.
Hmm.
And one, if people have kidney disease, they
Yeah.
probably should watch their phosphate. That's very important. Or if
Hmm.
someone is not consuming enough calcium,
Hmm.
then they're going to have a phosphate calcium imbalance.
Right.
But that shouldn't ever affect the general population. So
Yeah.
you definitely want to be aware of that for people that have those health problems. But for healthy people, I mean, phosphate's a normal thing to consume.
Yeah. Dr. Wes, I like to always ask folks that are first time on the podcast, how did you get to where you are in the meat sciences? What drew you to this category? I like to call discipline. Not everybody does, but how'd you get into
Well,
the meat sciences?
how long do we have,
A good
Phil?
3 hours. Is that going to cover
Three.
it, or okay?
That probably would. It'll at least get us started. Okay. So, um, I went to food science as an undergrad at Virginia Tech.
Hmm.
The whole reason I went is because my dad told me I had to choose a major, and my sister was already in food science.
Okay.
So I went to Virginia Tech to run track and cross country. So I
Okay.
did that for 5 years.
Wow.
But when I was there, Jim Claus, who is at University of Wisconsin now,
Hmm.
gave me the opportunity to work in his lab when I was a junior after my summer year. And it was just a great environment with 5 or 6 grad students, and I was a little peon undergrad there. And he let me start evaluating all of his data because he saw that I had a knack for it.
Hmm.
So I started doing all his statistical analysis and, just kind of found a home in it. And
Hmm.
so, I mean, I don't think I was ever looking for it, but, Jim Claus made a huge difference in my life there. I got a master's with him, and then I got a PhD with Norm Marriott.
Hmm.
And,
Wow.
um, I just loved processed meats and statistics and chemistry and and I knew that I needed to be institutionalized eventually. So eventually I got institutionalized as a professor,
We'll do it in a
But
voluntary manner this way, huh?
yeah, absolutely. But
Yeah.
but it's
And
good.
well, and you teach food chemistry, food chemistry, meat chemistry courses.
Well, actually, I'm in food science here
Hmm.
at Mississippi State. So my training is in meat science and meat processing, but I'm a food chemistry position. So I teach food analysis.
Okay.
I teach food chemistry. I run the sensory lab here, so I teach a food and flavor acceptance class, which is both sensory evaluation and flavor chemistry.
Okay.
So yeah, I don't know what I'm doing. I do a lot of different things. It's
I get the students in my office regularly. They're seniors, and I don't know what I'm going to do with my life. I look them right in the eye and say, I don't either. I'm just doing
yep,
this right now.
yeah, absolutely. And doing the best I can and enjoying it.
That's right. As long as you're having fun, it's not a job.
Yeah, absolutely.
So, all right. Well, Dr. West, I really appreciate you joining us. I think that was very impactful. Everything that you mentioned, I think it was very timely information that needs to be out there. Folks, read the labels and understand what it is that's going into our foods, and understand that there's good reason for them. And for the processors out there, don't be afraid to go ahead and use some of these incredible ingredients. Just make sure you use them judiciously. So, anyway, thanks everyone for listening, and we'll see you next time.
Right.